All right, so lesson 7b, we're still talking about the composition of functions. So it says the table of values for three functions f, g, and h are below. Find the values of each composite function operation below. So we can see that when x is -3, -2, -1, 0, 1, 2, and 3, we can see what f of x is equal to, okay? So they're just kind of ordered pairs written in a table. So when I'm looking for, when x is -3, so if I'm looking for g of -3, that answer is 0, okay? If I'm looking for h of 1, my answer is 2. So that's how we read that. So when I look at A, it says we're going to take 2 times f of g of 2 plus 3 times g of h of 0. So again, I'm going to work the left one, the right one, and then I'll add them together in the end. So remember, with composite functions, we're going to start with the inside, so g of 2. So our x value is 2. So go find g of 2, which is -3. And so bring down the rest of that. So now I'm looking for f of -3. So I'm going to go to where x is -3. And I'm looking at the f function, so that's -4. And then it still has that 2 in front of it. 2 times -4 is -8. All right. And then we're adding 3 times g of h of 0. So, oops, I'm trying to erase, sorry about that. So let's start on the inside. We're looking for h of 0, so go to where x is 0. H is 3. So now we're looking for 3 times g of that 3. So I'm going to look for g of 3. So I'm going to go to where x is 3. My g function says that it is 2. And then I still have that 3 times in front. 3 times 2 is 6. And then we just add those together. -8 plus 6 is -2. All right, same thing on B. H of g of -2. So let's go find g of -2. So go to where x is -2, g is -1. And so we're looking for h of -1. So go to where x is -1, and h is 1.5. And then we're multiplying, so times f of g of 2. So start on the inside, so g of 2. So go to where x is 2. Our g function says -3. And then we're looking for f of -3. So go to where x is -3. Go to your f function, which is -4. And then we just multiply them. What is 1.5 times -4? -6. All right, C says if k of x is equal to the absolute value of 3x minus 4, for what values of x is k of x equal to f of g of 0? Well, we know then, let me clear what I have marked on here. So it told us that k of x is equal to f of g of 0. So let's go find what k of x is equal to. So g of 0, so go to where x is 0 and g is 1. So we're looking for f of 1, so go to where x is 1 and our f function says it's 4. So we know then that k of x is equal to 4. Now the first part tells us that k of x is equal to the absolute value of 3x minus 4, which if k of x is 4, that means 4 equals the absolute value of 3x minus 4. So remember, with absolute value, when you take the absolute value, it's always positive. That's why it's a positive 4. But what's inside here can be positive or negative. So we could take the positive of what's inside, set it equal to the 4, and the negative of what's inside, set it equal to 4, and solve them both. So this is going to give me 3x minus 4 equals 4. Add the 4, so 3x equals 8. Divide by 3, so I get 8. X equals 8/3. I know we're not supposed to box, but I can tell I'm getting a little crowded here. Then I'm going to distribute the negative, so I get -3x plus 4 equals 0. Equals 4. Subtract the 4 over here. So that's going to give me -3x equals 0. Divide by -3, we get x equals 0. And so we need both answers to be able to solve. All right, then example 8 says describe the transformation of the composition of the functions given. So f of x equals x squared, g of x equals x minus 1, and h of x equals 2x. So for A, f of g of x, so f is my skeleton, and g of x we're going to plug in. So we know that our parent function is x squared, okay, so it's a quadratic, and the minus 1, remember, tells us that it is a horizontal, excuse me, shift or translation to the right 1. And so if I go to graph this, I know that that point there was a 0, 0 is over at the right 1, and then I just have my quadratic, my x squared. All right, B says f of h of x. So again, f is my skeleton, so it's x squared, and h of x is 2x. So that 2 is just a horizontal dilation. In this case, it's a compression, to be more specific, but a dilation works, by its reciprocal, 1/2. So remember, usually we multiply something by 2, it gets bigger. This one's going to get smaller. So horizontally, it's going to get smaller. We're going to compress it. It's going to become skinnier. So our vertex is still here at the 0, but it's going to be skinnier or more narrow. And then C says g of f of x. So g is x minus 1, and f of x is x squared. So we know x squared is still our parent function, but now it's got that minus 1, which means it's just going to be a vertical translation or shift down 1. And so where we started at 0, 0 before, we're just going to go down 1 and then graph. All right, example 9 says use the graph shown below and shown below on the right. Complete the table of values for f of x and g of x. Find the values for h of x, which is the composition of f of g of x. All right, so we're going to go through here, and we're going to find f of x. So I'm going to take, remember this one is our f of x. Whoops. There's my f of x. So when x is negative 4, it's here at negative 4. Negative 3, it's right there at negative 2. At negative 2, it's at 0. Negative 1, it's up at 2. At 0, it's at 1. At 1, it's at 0. 2 is 1. 3 is 2. And 4 is 3. All right, then g of x, that's this one here. When x is negative 4, its y value is 2. When x is negative 3, its y value is 1. X is 2, it's at 0, or negative 2, it's at 0. Negative 1 is down at negative 1. At 0, it's at negative 2. At 1, it's at negative 1.5. At 2, it's at negative 1. 3 is at negative 2. And 4, it's at negative 3. Now remember, the composition is f of g of x. All right, so I'm going to write out the first couple here. So we got f of g of negative 4. So we're going to go to negative 4, go to g, which is 2. And so then we're looking for f of 2, so go to where x is 2 and f is 1. So f of g of negative 4 is 1. All All right, then we got f of g of negative 3. So find g of negative 3, which is 1. And so then we're looking for f of 1, which is 0. Then f of g of negative 2. So look for g of negative 2, which is at 0. And f of 0 is 1. All right, and then we do the same thing. So f of g of negative 1. So g of negative 1, might be easier to write it out. So g of negative 1 is negative 1. And so f of negative 1 is 2. F of g of 0. So g of 0 is negative 2. So f of negative 2 is 0. And then we just keep following that pattern, okay? So we end up finding that f of g of 1 is 1, f of g of 2 is 2, f of g of 3 is 0, and f of g of 4 is negative 2. And then once we graph the points on the grid, x comma h of x. So we're just going to graph the negative 4, 1. Negative 3, 0. Negative 2, 1. Negative 1, 2. Okay, we're going to connect them in this order. 0, 0. 1, 1. 2, 2. Oops, went the wrong way on that one. Sorry. 1, 1. 2, 2. 3, 0. And 4, negative 2. All right, example 10 says for each of the following, find f composed of g, g composed of f, and the domain of f composed of g. Use a graphing utility to graph each composition function, determine whether they are equal.